building we're in originally, in Victorian times, was used for designing mechanical and electrical lifts for buildings, and it's quite apt that, in fact, we brought that back to life in some way, that we're engineers and we're designing lights. The process of how we work in this building is to look at and analyse lighting and find ways to dramatically improve them with efficiency, with engineering and innovation. We don't design to make things look good. We don't use that as a starting point. Our starting point is to investigate and experiment. I also really enjoy manufacturing. I love seeing manufacturing processes, how things are made. It's what makes you a better designer. I have workshops downstairs and I've got a machine shop downstairs, so within this premises in London we're able to design on computers, make things, prototype things and test things all in one space. It's a very interesting journey and there's always so much to learn. I spent 6 months looking at task lights and the problems with them, and the big problems that stood out was the lack of direction of light. And the arm of the light was positioned by springs and pivots, and those wear out over time. So wherever you position your light, it would drop. So we incorporated a completely new mechanism which was inspired by drawing boards and elevator lifts. The light moves up and down and rotates and moves in and out. And so we've rethought about the positioning mechanism for a light, so that where you position it, it stays where it is. And we've also hidden the LEDs up inside sort of conical cones, and that has two effects. It gives us a very even spread of light with no need for diffusers, so we have high efficiency on light output. So we sort of rethought about all the characteristics and function of a desk light and innovated in every single element of that. And that really sums up what we do here. My greatest innovation to date is probably the ability to cool LEDs, and it's something that's completely critical to the LED lighting market. The overall life of the LED is reduced if they're not thermally managed correctly. I'm not interested in selling lights that last for 7 years. I want to sell lights that last for 40 years. And I respect the technology and I want to do the best thing by it. So I think that the performance of cooling in the products that we've done is outstanding, and I hope will lead as a role model to other lighting manufacturers incorporating LEDs. If this was solid copper, it would take about 3 minutes for the heat to actually go from this end to my fingers. But now when I rotate it in the hot water, it's already there. It's very, very hot. And then I rotate it in the cold water, stir it in the cold water, and it's much, much cooler instantly. The speed that heat transferred up that heat pipe to my fingers is the same speed that the heat is being drawn away from the LEDs. So that's the principle, that's the technology we've applied into our products. It hasn't been a hindrance going down the same path as my father or inventing. In fact, I must say I think I find it easier to invent than replicate. I think if you've got good ideas, which I'm fortunate to have, then it's in some ways easier to start from scratch doing something no one else has done than it is to try and improve on something that someone else has done or might have done well. I guess the one thing that I have potentially learned from my father is don't give up, and that it's grueling, it's not an easy process and it's hard work. We don't make our job easy, but the end result is much more interesting.